Okay guys, let's do a last one now. 14.2. Again on DROTSKY page 215. Okay, let's do this one. Again is the cantilever. They ask us to use the error method to find what is the question? Calculate the deflection at the free end. We need to calculate the deflection at the free end. Deflection and the slope. Also, they ask us to find the deflection at 6 kilonewton plus at 6 kilonewton. Okay, first we're gonna start with error method. Wherever they ask you for a deflection, you must focus at that deflection. So in this case, we're gonna focus on the free end. This is for a free end video. Let's focus on it. I'm gonna come back with the last one to show you how to calculate for the 6 kilonewtons, the deflection under 6 kilonewton. So let's do the first one first. And now what you see, this one is different from the other videos whereby we have only one force. Now we have multiple forces. We have 9, 2 and then 6. So we have three things. We have a point force and then the UDL, right? So we have three things in this one. So when you are using an error method, I think the simplest thing is to separate. So we are using the principle of superposition, whereby we separate each forces. We just separate each force. We keep everything as it is, and then you just separate, like you do in chapter 6 on building beams and all those things, whereby you separate each beam and then you calculate the area. So we're doing the same thing here. So we're gonna separate. So this is a formal way or a technical approach, if you may say. So the first thing you do, you're gonna draw the whatever force you want to start. I prefer you, in order for you to get marks, you always start with point load because they are the symbol. Always end with the UDL, because if you do this, then 6 simple things first, you're gonna get marks, and also you're gonna have more time to concentrate on the complicated things like a UDL. So always start with point load. So you're gonna start with a point load of 6. So what do? Write A and D as it is. So this is your A up until D, your free wall, and then where it's 6 at, you write it 6 at here, and then what distance between critical distance is just 2 meters from the wall, and then from here to here is just 4 meters. So again, this is C. We call it C. You can name it whatever alphabet, right? After drawing it, you remember C is the same as B. So next to, not under, next to C, next to this, you draw a bending moment diagram. So for this one, you include A also, because why? They want a deflection at free end. A is your free end, so you must always include it. And then where is 6? 6 is here. What is the bending moment here? It's 0. Free end bending moment here is 0. Here it's 0. Here also it's 0. So at C, that's where it starts. This is C. And then after C, let's say this is D. After C, we have bending moment at D, which is 6 times 2. So minus 12. And then this distance is 2. Right? We have your A here. That's what you do. This is your bending moment diagram. This is kilonewton meters. Kilonewton meters. Right? After doing this, they ask us to find the deflection. So what is the formula for deflection? YA minus YB. So in this case it's D. Why? Because D is the wall. We always want to know one thing. From A up until D, M over EI. Up to you how to write it. X bar, don't forget, for deflection. And then theta A minus theta B, from A up until D, M over EI dx. So we have something like this, guys. So now we have to calculate. So we are starting with 6. So what do? this is a formal way of doing it, because this is gonna be a last thing we do. So the first thing we do, name it. This is your number 1, right? Because this is my number 1, obviously. So this area here is number 1, and then you say you find, always start with A1. What is my A1? This means the area. What is my A1? So it's gonna be, this is a right angle triangle, so it's gonna be 1/2 times 2 times minus 12. That's it. Then where do they ask you for the deflection? They ask the deflection at the A. So this is my A, and then from A, and then you have your x bar 1. Remember, 1 corresponds to 1. So what is my x bar 1? So it's got to, what is the distance here? It's 4. So it's gonna be 4 plus, this is a right angle, this is where the triangle begins, so it's gonna be plus 2/3 times 2. Then you get your answer. Then again you continue. What else? We have another point load. Again you draw, and then where does it x? It x here at 9,x7, and then the distance from here to the wall it's 4, and then from here to here is 2 from A, right? Then let's start again. Bending moment diagram. So what is the deflection at A? It's A. There's no deflection. What is deflection at 9? At what is called? This is B. At B, still 0. What is the deflection after? At D. This is D. What is the deflection at D? It's 9,7 times 4. So 9,7 times 4 is 38. So it's 38. It's positive. So it's upward. So it's gonna be like this, 38,8. Again, kilonewton meters. So this is B, right? The distance here is 4, and then distance here is 2, right? Then again, what is my x bar? They asked me the deflection at A, so my x would always gonna start at A up until the center. So this is my x2, this is my area 2. Then again you calculate, what is my area 2 is equal to 1/2 times 4 times 38. Take note, 38 now is positive. This one was negative. The answer here is negative. This one is positive. Then x bar 2 is equal to what? 2 plus, the triangle begins here, so it's gonna be 2 plus 4, 2/3 times 4. Then you have your answer. Let's continue. What else do we have? We have a UDL now. So number 3, we have a UDL. So we have something like this, and then the UDL starts at A and end at what? 1 meters. So somewhere in between. So it's 1 meter. So end. Let's call this point E. So it ends at E. So my UDL is 2 kilonewtons. So we have something like this. So now let's draw again. So yeah, E, from A up until E. So as we spoken last time, what is the bending moment here? It's 0. And then when you, in the cantilever, we always draw a curve. So before we draw a curve, we need to know what is the bending moment at E. So the bending moment at E is, what is this distance? It's 5. From here to here it's 5. From here to here it's 1. So it's gonna be 2 times 5 times 2,5. So the bending moment here at E for the UDL is 25. Right? So now we're gonna draw a curve. Here at A is 0. Then we curve always for the cantilever. Don't take my word. Always for the cantilever, it's gonna be the curve. We curve it. Then we write this thing is minus 25. Remember, UDL is going down. And then obviously we have this point also, 1 meters. So the UDL is still there. So it's gonna be 2,5. 2 times 5 times this distance, 2,5 plus 1, which is 3. So we have something like this, 3,5. So it's gonna be 2 times 5, the distance, then times 2,5, half of 5 plus 1. So we have 35, minus 35 because it's going down. So up until this point, minus 35. And then from here, there's no UDL over it. So we have something like this. Then let's zoom it for you to see it clear. So we have something like this here. So we have a curve here, and then straight line here. So if this was my 2, then mean this is my 3, 4, and then 5. And then we have this one is minus 25, this one is minus 35. Do you see? This one is 1, this one is what? 5. Right? Then again, so how many errors we have? We have error 3, which is equal to what? This is a curve, a parabola, 1/3 times what is the base of it? It's 5. What is the height? It's minus 25. You have your answer. And then also x bar 3. So my x bar, they asked me for the deflection from here. This is my A up until this point. So x by 3. So x by 3 is what? It's just 3/4 times 5. Or if you like, you can say 5 minus 1/4 times 5. Still gonna get a same answer. Yeah, but it's 15/5 or 3 times 5/4. Same answer. Then again, A4. Error 4 is equal to what? From error 4 is the square, so it's gonna be 1 times minus 25. And then x4, so from the way they ask me for the deflection to the center point, obviously it's not up to scale, so x4, we call it x4. X4 is just equal to, from here to here, it's 5 plus half of 1. So it's gonna be 5,5. Then error 5 is equal to is a right angle triangle. Remember, it was a straight line from here because there's no UDL above. So it's gonna be what? Distance from here to here, it's 10. So it's gonna be 1/2 times 1 times, what is this? 10. So it's gonna be minus 35 minus, that's 25. So it's gonna be 10 minus 10. Then again, my x bar 5 is what? X bar 5 is just from here to here, it's 5 plus half of this is what? It's not really half. Remember, this is a right angle triangle, so it's gonna be 1/2/3 because we are coming from the longest side to here. It's gonna be 2/3 times base is 1. So we have something like this, right? So we have all this equal, then you equate, right? Yes. Remember, this is the same thing. And then, is there any force that is left? Nothing. We have included all the forces, right? 1, 2, 3. We have included everything. Now they ask us to find the slope. It's just simple. So the slope at A is just equal to, again, we use the same formula, but now how many areas? We have many areas, so we modified the formula. It's just equal to a sum of A over EI. That's it. So it's gonna be A1 plus A2 plus A3 by A4 plus A3 5, then over EI. EI for this case, they gave us then you see at the blue book is 23,5 times 10 exponent minus 6 meters squared. Then E is what they give us as 200 GP. So substitute, and then you're gonna find your answer is what? As 5. For this question, they ask for a deflection. Obvious deflection, you're gonna find your answer. Then YA deflection is gonna, again, sum of A times X over EI. It's simple now, which is just equal to A1 X1 plus A2 X2 plus A3 X3 plus A4 X4 and plus X5 over EI. Remember also this is kilonewton, so multiply by 1000, because this is SI unit. This one will give you kilonewtons, so multiply by 1000 SI unit, and then you're gonna get at the end 55.1 millimeters. So you convert it up until millimeters. So yeah, that's it. This is the error method for the complicated part. You separate, right? This is for a cantilever. You just separate. It's easy, Saint. It's easy. It's easy. I said close them doors. It's easy. So recap, just a quick recap. So if it's like this, you separate into individual. That makes sense. Remember, you include everything, right? It's just a simple drawing, but with one force you draw, one force you draw. If it's positive, it's up. If it's negative, it's down, right? Again and again and again. Just one force, one force. Don't complicate your life. Don't draw two forces, right? Just one force, one force. It's gonna be easy. If you're gonna decide to draw everything in one step, you're gonna miss it. You're gonna mess it up, especially if there's a UTL. Try to separate, right? So you have something like this, and then you have your answer. Now I'm gonna show you a 6 kilonewton video and how to calculate for a deflection, because now they're asking the deflection at a different point from the same thing. How do you approach this one now? So now I'm gonna show you. Let me just upload this video.